Today, we're going to recreate Unity's URP lighting model in Shader Graph. Let's go! Alright, so we're in the middle of a series of videos about creating lighting in the graph. Last week, I showed you how to create URP's specular highlights. Today, we're going to build the rest of the lighting model, including the ambient and the additional lights. When we're done, you'll have a graph that closely imitates the lighting model that URP uses, and this is cool because you can then customize that however you want to get the look you're going for in your game. By the way, if you haven't seen the rest of the videos in this series, I'll put a link to the playlist down in the description so you can catch up. We're going to be starting where we left off from last week, so you may need to go back and work through previous videos in this series if you haven't already. Alright, so let's take a look at the shaders that we're working with. Most of the shaders in this scene have been replaced by a shader that's doing the lighting in the graph. So here's our shader called URP Custom Lighting. And inside of this shader, we have a subgraph here called Lit. And Lit looks like this. It has a whole bunch of lighting models. And these are all of the lighting models that we've been working on in the series so far. And right now, the one that we have hooked up is called URP lighting. So this is where we're working. Last week, we created the specular highlights inside this lighting model. And today, we're going to fill out the rest so that the lighting model works the same as URP's, the code version of URP's lit shader. Okay, so let's go into URP lighting here and we'll take a look. All right, so you can see that it's made up of several different components. Here we have our diffuse lighting. Here we have our specular lighting that we worked on last week. Here we have our reflectance that determines how bright the specular and the reflections are. Down here we have our ambient component, and then over here we have our additional lights. So our diffuse and specular here are being calculated for the main light, and then diffuse and specular for the additional lights are being calculated here. So today we're going to focus on our ambient node, and we're going to focus on our additional lights node. And like I said, by the end we'll have a shader that behaves very similar to the way that URP's built-in code lighting works. Alright, let's start with the ambient node here. What we need to do is come down to our project window and pick our ambient simple SSAO. This is a node that we created in a previous video. And I'm just going to copy and paste it. And we're going to call this new version ambient URP. And we'll open it up and get started. Now, the first thing that we need to do is there's this node called reflection probe, and it's sampling from a reflection probe. But this node, all it does is sample one probe in the scene. It samples the sky reflection probe. And we actually want to make a node that samples whatever reflection probe we're closest to. And so we need to replace this reflection probe node with one that does that. So I'm going to come down here to our ambient folder, and I'm going to right click in here, and I'm going to pick create shader graph subgraph, and we're going to call this sample reflection probes because that's what this subgraph is going to be doing. All right, so I'm going to open this up, and we need to make some inputs in our blackboard. So we need to input the position in world space. So I'll make a vector 3 and call this position WS. We need to make the reflect vector. So I'm going to add another vector 3. We'll call this reflect vector. We need to add the smoothness. So I'll add a float and call this smoothness. And then finally we need to add occlusion, so I'll add a float and call it occlusion. So these are the parameters that we need to pass into the function that we're going to create that builds or that samples our reflection vector. So we'll bring in our world space position, and we're going to add a default world space position here. So I'm going to use a branch on input connection node. And for position world space, I need to open up our graph inspector here and check this use custom binding box. And then I'm just going to give it a position WS label there. Okay, now we can connect this up to our input and to our connected. And when our input port here is not connected, we're just going to give it the default of the position in world space, and we'll connect that up to our not connected port. All right, so there is our position input. We need to do something very similar for our reflection vector. So I'll bring in the reflection vector. I'm just going to give it a use custom binding, and we'll call this reflect. And then we need a branch on input connection node. And here we're going to calculate the default reflection vector. So in order to do that, I'm going to bring in the view direction node. And I'm going to negate it because we want it to go the opposite direction. And then I'm going to use the reflect node to calculate the reflection vector. And we need to calculate the reflection vector between the view direction and the surface normal. So I'm just going to bring in the normal vector node and hook that up to our reflection vector. And so this is calculating the reflection vector between the camera view and the normal. And so this is what we're going to use for our not connected. So there's our reflection vector coming in. And when it's not connected, we're going to use this version of it that we've calculated internally. Okay, the next thing that we need is the screen position. So I'll bring in our screen position node. And then finally, we need our smoothness down here, and we also need our occlusion. And all of these are going to be inputs to a custom function node that I'm going to make. And so I'll just kind of line these up. Now we can make our custom function node and pass all of these parameters into it. So here's our custom function. And the inputs that we need for it, I'm going to open up our graph inspector here and add our inputs. We need position in world space. And that's going to be a vector 3. And we need our reflect vector. And that's also going to be a vector 3. And we need our screen position. And so we'll just call it screen pos. And that's going to be a vector 2. And then we need roughness and occlusion. All right, so there are our inputs, and our output is going to be called reflection. And it's going to be a vector 3. Okay, so now we just need to hook up our parameters. Here's our world space position, our reflection vector, our screen position. So here we have smoothness coming in, but this function is calling for roughness. And so for that, we need to give it a 1- to invert that value. And then we've got our occlusion, and we'll just wire that directly in. And so now we're ready to create our function. And so for the function, I'm going to come up here, and instead of file, I'm going to pick string. We need to give our function a name, so I'm just going to call it sample reflection probes. And then I'm going to copy and paste the code here. And just so you don't have to type the code in here, I'm going to give you the text of this code down in the description. So here's the code we're using. First, we isolate the shader graph preview, and we just make our reflection vector 0, 0, 0 if we're in the shader graph preview. But otherwise, we're going to be calling this function called glossy environment reflection. And this is a function that's built into URP. So we're using URP's code for calculating our reflection vectors. And we're passing in our reflect vector, our position in world space, our roughness, our occlusion, and our screen position. So that's going to give us the result that we're looking for, which is the output of our reflection. Okay, so now all we need to do is pass this out, and our output here is going to be a vector 3, and we'll just call this out. So again, what this subgraph does is it samples the reflection vectors in our scene and gives us the result from whichever reflection vector is closest to our object. And this is exactly how URP is calculating our reflections. Okay, so what we need to do now is save our sample reflection probes node, and we need to come back to our ambient, and we need to bring this in. So instead of using this reflection probe node here, now we're going to be using this sample reflection probes node instead. All right, so let's take our view direction here, and I'm going to negate it so it's going the opposite direction. And we're going to pass our view direction into, let's see, we need to calculate our reflection vector. So we'll put in a reflection node and pass our view direction into that. Then we need to pass our normal into it. Here's our normal in world space that we've calculated previously. And we'll wire that into our reflection vector and then pass that into our sample reflection probes node into the reflection vector input. And for the position in world space, we can just go ahead and use the default that's coming in there. But we also need our smoothness and our occlusion. So let's see what we have in our blackboard here. Here's our smoothness. So we'll just wire our smoothness directly in. And we can delete these other nodes here. And we have an occlusion input here, but in this case, we're not going to be using this directly. I'm just going to set this occlusion to 1 because we want to do something a little bit different with our ambient occlusion. So the next thing that we need to do is take the reflection probes data that's coming out of here, and we need to multiply it by our reflectance. So I'm going to add a multiply node, and then I'm going to bring in our reflectance here, and we'll just multiply it by that. And we're going to put these objects here inside our group, and then just kind of clean things up a little bit. I don't need this input here anymore, so I'm going to get rid of that. So here's our specular ambient calculation. Let me just double check it really quick to make sure that we're doing everything that we need to be. I'll just kind of clean things up here a little bit. Okay, yeah, that's what we need. So this is our specular ambient. Let's go ahead and calculate our diffuse ambient. So we're going to be using this baked GI node, and we can just go ahead and minimize that. And all we need to do is multiply our baked GI by, let's see. We just need it to look like this. We can delete these here. We do need our ambient occlusion node, but we're going to rearrange this a little bit. So I'm going to ungroup this one. So here's our diffuse ambient, and that's all we need to do. We're basically taking the global illumination and then multiplying it by either our base color or by 0, depending on if our surface is metallic. And so that's going to give us our diffuse GI. And then we need to add that together with our specular ambient. And then once we've done this add, now this is where we need to include our screen space ambient occlusion and our regular ambient occlusion as well. So let's bring in our ambient occlusion. Oh, we got two of them there. We can delete that one. And now we're going to see whichever of these is less. I'm going to use a minimum node. So we're going to say whichever is a smaller value between our ambient occlusion and our indirect AO. And that we're going to multiply here. And then pass that out as our ambient value. But then we also need a value to pass out for our direct AO. So for that, again, we're going to do this minimum calculation. We're going to say whichever is the smaller between the ambient occlusion and the direct AO that we've got here, and we're going to pass that out as our direct AO. Okay, so we're calculating our ambient value and our direct ambient occlusion value, and we're passing those out as part of our ambient subgraph. Okay, so this is how ambient is calculated in URP's lighting model. Okay, so now that we've got our ambient all set up here, we need to go ahead and come back to our URP lighting and bring our ambient URP subgraph that we just created into our scene and then hook up all the wires. So I'm going to hook up our normal. I'm going to hook up our base color, our metallic, our smoothness, our ambient occlusion, and our reflection, our reflectance, and that should do it for us. And now we need to go ahead and hook this up to the rest of the graph. And so here you can see we have our ambient simple SSAO, and we're bringing the result over here and adding it in at the end. So I'm going to hook up our ambient URP to that instead. And then we also need to wire out our direct occlusion, or our direct ambient occlusion. And it's coming up here. Let's see. I'm going to change this around a little bit. What I'm going to do is bring in our base color, and we're going to multiply that by our direct ambient occlusion. And then we're going to take this node here where we're lerping between our base color and 0 based on metallic. And instead of this base color node, we're going to wire in this base color that has our direct ambient occlusion multiplied in. Okay, so there we have our base color calculation, kind of taking into account the metallic and also multiplying by our direct ambient occlusion. And then for the output of our additional lights here, by the way, we're going to get to our additional lights in just a minute. We're going to take the diffuse output of this and multiply it by our base color calculation that's coming out over here. So we're going to do it just like that. And then we're going to add in our, I'm just going to delete these extra. Then we're going to add in our specular contribution. So I'll add this and wire out our specular. And then we need to multiply by the color coming out of our specular. So I'll create another multiply node, multiply all of that by the color. And then we'll connect this up with our add down here. And then we calculate our fog and we pass out the results. So yeah, cool. That is going to do it for our lighting model. The one last thing that we need to do is this additional lights node. So this is calculating the diffuse and specular lighting for all of the extra lights in our scene. And what we need to do is, so last week we calculated these specular highlights here for our main light source, and we need to update our additional lights node so that it's doing the same specular calculations for our additional light sources. What I want to do really quickly before we jump into that is I want to show you what the specular looks like over here and why we're doing this. If you take a look at this rock here, and also this is really noticeable on this wall. Let me just maximize our scene. Can you see how this specular highlight feels really broad and kind of like it's just a little bit too glossy? This is the reason that we're switching to this new type of specular highlight. Last week we calculated for our directional light, but this lighting here is coming from this light source, this spotlight here, and it doesn't feel very natural. And this is because the specular highlights that we're using right now are cheaper. They're using the blend formula, which is fine, but it doesn't look quite as nice. And it obviously doesn't match the way that URP would do it. And so that's why we are switching our specular formula for the one that URP uses. So we need to find our additional lights subgraph. And I can just come down here to lighting, additional lights. And I'm going to copy this additional lights node here and paste it. And we're going to call this one Additional Lights URP. All right, so let's jump into our Additional Lights URP subgraph. And we'll go ahead and alter this one so that it's doing what we need it to do. Okay, right off the bat here, I can see that we're inputting specular power. And we actually need this to be smoothness. So I'm just going to pick specular power here and rename it smoothness because this new specular formula uses smoothness instead of specular power. And then we need our position. We need our incoming world normal. We need our view direction. We need main light diffuse, main light specular, main light color. And we need our screen position. And then we're going to be outputting diffuse, specular, and color. So all of this is good. I think now the only thing that we need to change here is the actual code that we're using in this custom function node. So let's open this up. And again, we're going to take our specular power here and rename it to smoothness. And let's just double check all of our inputs. We have smoothness, world position, world normal, world view, main diffuse, main specular, main color. We need a reflectance input. So let's add a new input here. And we're going to call this reflectance. And it's going to be a float value. And we'll just put it right there. And now let's go over to our blackboard and we'll create a new parameter here, float, called reflectance. And we'll just drag that in and wire it into our reflectance input there on our custom function. Then we'll make a space for it and just stick it right into our lineup. All right, so we're going to name our additional lights custom function add additional lights URP. And then the body of our code needs to go right here. Okay, so this is where it gets kind of complicated because there's a lot of code in this box and it's kind of hard to see what's going on in this box. So what I'm going to do is take the code just from off screen and copy and paste it in here. And then I will put this code down in the description. And we can take a look at what this is doing in just a minute. But let's go ahead and select all of our code. And I'll paste in the new updated version. So this is basically doing the same thing as we were doing before, with one main exception. And the exception is down here where we're calculating the specular. So here we have this comment that says direct BRDF specular. And this specular formula is the one that is specific to URP. So this is what we did in last week's video. We made the nodes that recreated this type of specular highlight here. And now you're seeing it in code form. This is what the code looks like for the node graph that we created last week to calculate that specular highlight. Okay, so now we should be able to save this and go ahead and hook up our additional lights URP to the rest of our graph. So we'll switch back to our graph, and we already replaced our ambient node, so that means we can delete this ambient simple SSAO node here, and we'll put our ambient URP node in its place. And now we need to do the same for our additional lights node here. We'll drag in our additional lights URP node that we just created, and we'll replace our additional lights node with this new one. So I'm going to hook up our diffuse, I'm going to hook up our specular, I'm going to hook up our color, and now we need to hook up the inputs. So we'll take our main light coming in here, we'll take our main light specular, we'll take our main light color, we'll grab our normal in world space, we'll grab our smoothness. Now here, we have this adjust smoothness thing going on, but what we actually need to do is wire this smoothness directly in and skip that adjust smoothness block there, because we're no longer using the specular power. Now we're using the smoothness instead. So we can delete this one. And then we need to wire our reflectance in from our reflectance subgraph here. Alright, so now we've connected up our additional lights node, and we should be good to go. I'm just going to double check everything, and then we're going to switch over to our scene and take a look at our results. Okay, I did find that there is one more thing that we need to do, and it has to do with keywords. So let's go ahead and do that now. This is the shader that we're using that's applied to most of the objects in our scene. And you can see that we have a couple of Boolean keywords here in our blackboard in the shader: cluster, light loop, and light cookies. And I'm going to just go ahead and delete these, because what I want to do instead is put these keywords in our lit subgraph. So this is the main shader, but then we have this subgraph where all of the lighting is taking place, and I want to put our keywords in there instead. So I'm going to delete the cluster light loop keyword and the light cookies keyword and save our graph. And then I'm going to come here to the lit subgraph, and this is where all of the lighting models are that we've been working on. And the one that we are working on today is this URP lighting. So right in this subgraph with all of our lighting models here, I'm going to paste a set of keywords. And I'm also going to put these keywords down in the description so that you can get them correct. But basically we have cluster light loop, light cookies, reflection probe blending, reflection probe box projection, reflection probe atlas, soft shadows, additional light shadows, and main light shadows cascade. And these are keywords that turn on functionality in URP's source code. So we need to make sure that these are in our blackboard. And then if we come over here to the graph inspector, for each of these keywords, we need to set them to multi-compile, is overridable, and then default value true. And this is going to allow us to turn on sections of code in URP that will activate the features that we're looking for. Now that these keywords are in here, we can save this, and then again we'll save our main shader, and we'll switch over to our scene, and it's going to recompile, and we'll just maximize this here. Now I can fly around, and what you're going to see is that we have our shader graph shader that's doing all of the same lighting calculations that URP is doing. We've recreated URP's lighting model in shader graph. And the really powerful thing about this is that now that this is done, I can go into that shader and rearrange things and do whatever I want. You know, I'm starting from a base of this is what URP does by default, but now I can come in here, I can change the specular, I can change the additional lights, I can change the way the ambient works or the ambient occlusion, all of those things because I have control of it in the graph. It's no longer kind of under the hood in code. Now I have it in the graph where it's easy for me to edit it. And I think this is super powerful. I don't know about you guys, but I'm really excited about the potential that there is here for artists and designers without any coding experience now to be able to customize the lighting model and make URP do exactly what they want it to. This is, to me, this is just super cool. And I hope you guys like it. All right, well, that's our video for today. I hope you enjoyed it. Be sure to come back next week. We're going to continue on our journey of customizing lighting models, and it's going to be great. So subscribe if you haven't already. Tune in. We're going to keep doing more custom lighting models. Thanks for watching, and I hope you have a great week.